I just had to let you know you're.
Assalamualaikum and hi. Today we are going to present about a sustainable technology for heat reduction and energy efficiency. In this presentation, we will talk about the introduction, methodology, finding method, discussion, conclusion, and also reference. This slide shows the background of study. First of all, global warming is causing rising temperature around the world. Malaysia required more cooling and consume more electricity. The sustainable construction solutions are required to improve thermal comfort and reduce energy consumption. Lastly, green roof systems are one of the most efficient passive cooling options. The objective of this assignment is first to provide an overview of green roof system, to evaluate thermal performance and energy saving potential, third to analyze environmental, economic and social benefit, fourth to identify current application in Malaysia, and lastly to investigate current research trends and future development. This slide shows the methodology that we use in our research. We choose a literature review approach, which means our study is based on information from previous research instead of conducting experiments. First, we conduct a genesis using Google Scholar and other scientific databases. We use keywords such as green roof system, thermal performance, energy efficiency, urban heat island, and stormwater management to find relevant articles. Next, we selected 10 peer-reviewed journal articles published between 2020 and 2025 to ensure the information was recent and relevant. After that, we compared the findings from the selected article and analyzed the data to identify the benefit, performance and challenges of green roof system. Finally, we drew our conclusion based on the overall finding from the literature.
The study adopted a literature review approach by reviewing 10 peer-reviewed journal articles published between 2020 and 2025. The selected studies used different research methods, including field experiments, simulation studies, monitoring studies, review articles, and economic analysis. Using various research methods provides a more comprehensive understanding of the performance and applications of green roof system. Each research method has its own strengths and limitations. The selected studies provide reliable scientific evidence because they are published in peer-reviewed journals and involve different research approaches. However, the findings may vary depending on climate conditions, vegetation types, and roof designs. Therefore, the performance of green roof systems may differ in different environments. This diagram shows the main components of a green roof system. It consists of vegetation, growing medium, filter layer, drainage layer, waterproof membrane, and roof deck. These layers work together to reduce heat transfer, improve thermal insulation, retain rainwater, and protect the building structure. Based on the selected studies, green roofs significantly improve thermal performance. Kachenchan and Pan Prayun 2024 reported a roof temperature reduction of up to 12 degrees Celsius. Guaido Santos et al. 2025 found indoor temperatures were reduced by 3 to 5 degrees Celsius. Overall, green roofs reduce heat gain and improve indoor thermal comfort. Green roofs also improve building energy efficiency. Guattari et al. 2020 reported a reduction in cooling demand, while Pragati et al. 2023 found that total building energy consumption decreases by 10.5%. These findings show that green roofs can reduce electricity usage and lower cooling costs.
Now, I'll explain the environmental benefit of green roof system. First is urban heat island mitigation. Green roof help lower the temperature in city by absorbing less heat than conventional roof. Studies show that they can reduce surface temperature by around 2.7 degrees Celsius, making urban area cooler and more comfortable. Second is the stormwater management. Green roof absorb and store rainwater, which help reduce surface runoff and the risk of flooding. They have a retention rate of about 81 to 87% and a detention rate of around 83 to 87%, meaning they can effectively manage rainwater before it enters the drainage system. Lastly, green roof contribute to carbon reduction. The plants capture carbon dioxide through photosynthesis, helping to reduce greenhouse gas emission and improve the air quality. Next, biodiversity benefit.
They provide habitat for birds, bats, and arthropods such as bees, butterflies, and insects. These species play an important role in pollination and maintaining healthy ecosystem. Green roof also improve habitat connectivity by creating green spaces that allow wildlife to move more easily between different areas. As a result, they increase urban biodiversity and help restore natural ecosystem within cities. Next, economic and social benefit. From an economic perspective, they help lower electricity bills by reducing the needs for air conditioning. They also reduce cooling costs, extend the lifespan of the roof by protecting it from extreme weather, and provide positive long-term return on investment despite the higher initial installation costs. From a social perspective, green roof improve indoor comfort by keeping building cooler. They also enhance the appearance of urban area by adding greenery and create a healthier living environment with better air quality and more pleasant surrounding. Next, the application of green roof system in Malaysia. Currently, green roofs are being implemented in residential, commercial, and institutional buildings as part of the sustainability building practices. However, there are still several challenges. These include the high initial installation costs, limited expertise in design and maintenance, and limited public awareness about the benefit of green roof system. To encourage sustainable development, Malaysia used several green building assessment tools, including GBI, MyCREST, and Green RE, which promote environmentally friendly building design and practices.
Now, let's move on to the research trends and future prospects of green roof systems. Recent studies focus on improving the efficiency and sustainability of green roofs. Researchers are developing smart irrigation systems to reduce water usage, creating lightweight growing media to minimize structural loads, and selecting drought-resistant plants that are more suitable for tropical climates. Another growing trend is the integration of green roofs with solar panels, also known as biosolar roofs, as well as AI-based monitoring system to improve maintenance and overall performance. Looking ahead, green roofs are expected to become more widely adopted in residential, commercial, and public buildings in Malaysia. With stronger government support and increasing awareness of sustainable construction, green roofs can play an important role in achieving net zero carbon and creating greener cities. So, based on the studies we reviewed, most researchers agree that green roof systems provide significant environmental and energy-saving benefits. The findings show that green roofs improve thermal performance, reduce indoor temperatures, lower energy consumption, and contribute to a healthier urban environment. However, there are also some differences in the results. Their performance depends on several factors such as the local climate, the type of plants used, and the depth of the growing medium, which can affect both cooling efficiency and stormwater retention. Although the initial installation cost is relatively high, the long-term savings on energy, together with the environmental benefits, make green roof systems a worthwhile investment. Therefore, they have strong potential for wider implementation in Malaysia's tropical climate. In conclusion, green roof systems are an effective and sustainable solution for reducing heat gain and improving building energy efficiency. They not only improve thermal performance and reduce energy consumption, but also help mitigate the urban heat island effect, enhance biodiversity, and improve stormwater management. Overall, green roofs support sustainable urban development and contribute to a greener and more climate-resilient future. With Malaysia's tropical climate and increasing focus on green building initiatives, green roof systems have great potential for wider implementation in the years ahead. Finally, these are the references that we used throughout our study. And that's all from us. Thank you for your attention.